All right. So good evening, everybody. So for college algebra, I have a collection of quizzes that I used to give, and I changed them. I changed at least one problem per quiz per semester. But I thought, part of going over our review, part of going over, reviewing for our exam next week, is to let you see like what kind of questions have I ever asked before, right? And this is one of them. I told one of the questions that we have in Alex is, here are the endpoints of a circle, right? Endpoints of a diameter, and we'd like to write the equation of a circle given this information. So why don't we just walk through this and see what we have, all right? Because I almost guarantee you that because I know there's at least one question that you guys have for homework that asks you this question. The numbers are different, but I guarantee you I will ask you that question. I just like this question for circles. It makes you do everything that you ever had to know about circles. Okay. So the first thing I'm going to do is I'm just going to draw this because I think that's, you don't have to draw it, but I do find that, having a little bit of a visual here kind of cements like, what am I talking about? So here we have the point -4, 2. And then we have 1, 2, 3, 4, 5, 6, and somewhere in here. And then 1, 2, 3, 4, 5-ish. So in here. So if we try to draw a circle here, all right, if we try to draw a circle around this, we'll use this color. All right. We're going to make that the diameter, right? We're going to pretend that's round. And the idea is that we want, we have a diameter here. We have to do a couple of things, right? We have to figure out where's the center, right, from my crummy drawing. And then we have to figure out the distance between this. Okay, so the goals that we have, right, is figure out the midpoint. And then we're going to get the distance of this diameter. Once I know where the midpoint is, I'll know where the center of the circle is. Once I know the diameter, we can figure out the radius. Okay, so to figure out the diameter, right, all we're going to do is we're just going to average the ordinates. Okay, that's all we do for midpoints. Is like, well, where's the middle? So this is, the x midpoint, I'll call xm. Okay, that's equal to -4 plus 5.6 all divided by 2. Okay, the y part of the midpoint, okay, that's going to be 2 plus 4.8 all divided by 2. All right, so I think we have $5.60 minus $4. That's going to give me $1.60. $1.60 divided by 2 is 0.8. Okay, so my x midpoint, 0.8. Okay, the y midpoint, we have 2 plus 4.8. That's going to be 6.8 over 2. Nearly 7. So half of 7 is 3.5. I think that's going to be 3.4. Okay, and we can come over here, right? 0.8. So here, okay, 1, 2, 3, 0.4-ish. Okay, that's not so bad as far as coming up with a midpoint. Okay, if we made a better drawing, this would fit a lot better. But you're not supposed to find the midpoints by looking at your drawing and figuring it out from there. You should do it analytically. That means use the formula. Okay, so you really do get a better, you get a more accurate reading of what this midpoint is. Okay, that's why there's decimals in it. It's because there's too many students that draw this thing out and then they just use the squares on their graph paper. No. Okay, so my midpoint is here. That's the center of my circle. So already with our circle, we can say this is x minus 0.8, 0.8, squared plus y minus 3.4 squared, right? Because remember, a circle is, right, is x minus the horizontal part of the middle plus y minus k. Again, I don't remember the Greek word for elevation, vertical, but it does start with a kappa. And we still have to figure out what the r is, okay? Now, we can get the diameter of this thing. We can get the length of the diameter, okay? So I don't know if you remember, there is a formula, and you are welcome to use the formula, but it's also this, right? It's this triangle, okay? So it's this distance squared. So it's whatever this vertical distance is squared. I'm going to say this y2 minus y1, right? That's what this is. It's this distance in elevation. And then this horizontal distance, that's x2 minus x1 squared, okay? And that's what this distance is. But if you don't remember like this formula thing, I mean, this is why we drew the picture, was so that you could come back to this and say, oh yeah, that's right, it's a triangle, and I can do the Pythagorean theorem, and that's exactly how it works. And that is exactly how it works, all right? So we have what? We have negative 4, 2. Oh, I wrote it down right here, negative 4, 2. And what is this point? This point was 5.6, 4.8. This is 5.6, 4.8. All right. So what is my horizontal distance here, right? Just the horizontal part. So we're going to take the x minus this x, okay? So this distance here, right, the horizontal distance, the base of the triangle, you call it that way because that's what it is, 5.6 minus negative 4, okay? This 9.6. Okay. Vertical part, right? That's 4.8 minus 2, okay? It's 4.8 minus 2. And it looks like we end up with a 2.8 there, okay? So now, we have a triangle. We just redraw it, okay? We have a 9.6 here. We have a 2.8 here, up and down. And I'd like to know what's the hypotenuse. That's the distance. That's the distance of the diameter. All right? So you go back to your geometry class, right? Because I know you remember that like it was yesterday. And we're going to say that distance squared is equal to 9.6 squared plus 2.8 squared. And then we're going to do one better. We're going to go ahead and we're going to take the square root. All right, and I'll say a couple of words about this as soon as we get done with that. Okay, so let's see what we have here. We have 9.6 squared plus 2.8 squared. That's equal to the diameter. Diameter is equal to the square root of 100, which is 10. Okay, and that's the diameter. So the diameter is all the way across the circle, right? It's the whole thing. That's 10. I don't want the diameter though. I only want the radius. So the radius is equal to half of the diameter, and that's going to be 10 over 2, which is 5. Now when I come back to this formula, right, we had r squared. Okay, so we're going to say, okay, great. The formula for my circle, x minus 0.8 squared plus y minus 3.4 squared is equal to 5 squared, or 25. All right, I shudder to put this on the internet for the next little thing here. Okay. All right. One of the biggest problems I see students make with distance formula is they say, oh, I've got a square root and two squares. I could just undo the squares in the square root and just add these together. And that's not going to work. So just to give us a really easy one with real easy numbers, okay? We'll call that 4, we'll call that 3, right? And if you did any geometry at all, right, there's our c squared is equal to 4 squared plus 3 squared, so 16 plus 9. C squared is equal to 25. C is equal to 5. All right. So if you're going to start here, you'll know why that little house is there in a minute. If you're going to start here and you want to get home as quickly as possible, okay? Are you going to take all the way around? Are you going to travel the 7? Or are you going to travel the 5? You're going to travel the 5, okay? And the story I usually have for this is when I was going to school in Socorro, I lived in a neighborhood that people let their dogs run wild, and there was like a pack of wild dogs I had to get away from as quickly as possible, like daily. So the dogs know that if they cut across, okay, they're going to get to your house before you will, and then you're going to be lunch. So if you're going to be polite and walk all the way around here, the dogs are going to catch you. So if you decide, I'm going to get rid of the square roots with the squares, you're going to be lunch, because that is going to be a lot that I'm going to take off for making that mistake. Okay, so realize that bad mistake, and yeah, the dogs know to cut the corner. All right, be at least that smart. Okay, so that's the big pitfall here. So the two pitfalls are here, and I've fallen for this. You get so excited that you got a number here, and then it worked out, kind of like it came out of a textbook, or it was planned. You're welcome. That we get the 10 here, and then we forget to get half of it, and get the radius instead. So be careful. This mistake, this when you were doing it by hand, I didn't care about. I mean, I still got you for this mistake a little bit, but for the most part, the mistake that I really worried about was this one. Okay, there's a lot of places you can go wrong. This, it would take you from an A to a B for doing this, as opposed to doing, this. That would take you from an A to a D or an F. I would just half credit is best at this point. So that's what we have there. Okay. So yeah, there's my circle. Okay, that's what it asks us to do. Okay, so this is not going to quite work the way that that we're going to do here, but that's okay. They asked us to do a lot of x-intercepts, right, when we were messing around with the Alex yesterday. So this problem, right, f of x equals 9x squared minus 13x minus 10, and they want to know what's the x-intercepts. Well, that's where y is equal to 0. Okay, so that's where y is equal to 0. So we're going to say this is 9x squared minus 13x minus 10 is equal to y, 0. Now, first thing you might ask is, like, how am I supposed to factor this? Okay, it's a minus 10, not a 0. Oops, wrong one. There we go. So what we're going to do is we're going to use something called the AC method. Okay, you're going to multiply the first number and the last number, and we're going to get 90. Technically, we get negative 90, right? So this is 3 times 3, that's 9, times 2 times 5, that's 10. 9 times 10 is going to give us 90. And what I need to do is I need to come up with numbers that are going to multiply out to 90, negative 90, but add up or have a difference of 13. Okay, negative 13 here, right? So the way we do that, right, is we say, okay, well, 1 and 90, 90 minus 1, or 1 minus 90 is negative 89. This ain't it. Okay. Oops, wrong one. We'll do that one. Okay. And then what we're going to do is, okay, well, how about 2? What's left from 2, right? We have 9 times 5. It's 45. That doesn't add up to 13. And we have 3. What do we have left from 3? We have 10. We have 30. 30, 3 minus 30, that ain't going to do it. I don't need 4, but 5. 5's part of here. It's part of my list. So we're going to have 9 times 2. Right? That's 18. I think we have a good candidate here, right? 5 minus 18 will give me negative 13. For the sake of argument, I'm just going to keep going with this little piece here. So we have a 3, we have 2, 3, and a 5. Now we have to start combining them. Okay, 2 times 3, that's 6. If I take out a 3 and a 2, we have 15 left. All right. And then I think the only one I have after that is 9. That's the next one up. Right? Because I can't make 8. I can't make 7 out of here. So we have 9 times 10. And after that, they start going around again, right? We're going to have 10 and 9. You don't need to list them again in reverse order. Okay. But those are all the different pairs we have of things that add up or things that multiply out to 90. All right. There are other ways to do that. If you don't like the way I do it and you want to do it with like figuring it out this way, that's fine. You don't have to do it my way. All right. But here's what we're going to do for this thing. We're going to say, well, this is 9 squared, 9x squared. This is negative, so we need a bigger negative than a positive. Negative 18 plus 5 will be negative 13. Now, it doesn't matter which order you write these in, but since this has a 9 in it and this is divisible by 9, I'm going to group these two together as firsts. This is a 5, this is a 5. I'm going to group them together as seconds. Okay, so I just try to get like as much like possible as I can, but there's no, you must do it, you shall do it this way. That isn't a thing. Okay. But what we're going to do is we're going to pull out the 9x here. If I pull out a 9x, we've got 9 minus 2. If I multiply this back, we get the same thing here, right? Plus 5, x minus 2, this equals 0. Okay, so to factor this thing, okay, x minus 2's come out. 9x plus 5 is left, equals 0. All right. So my intercepts here, right, are x is equal to 2, and I got to solve this. So I'm going to say 9x is equal to negative 5, x equals negative 5/9. Okay, those are my 2 zeros. So 2, 0, negative 5 over 9. Okay. Oops. Let's put it in the way they want us to put it. Like that. Okay. So that's, yeah, again, in a face-to-face class, I try to do a lot of these because I know that you forget how to factor. So I try to remind you, make this a skill you're practicing on a regular basis. I've noticed even in the ALEX, they don't really reinforce this too well. But if you're good at factoring, well, it won't necessarily mean you're going to be good at calculus, but being able to factor well helps a lot with calculus. This is called the AC method. If you want to watch somebody else on YouTube do this, because it's very powerful, there is a YouTube channel called Math by Fives. And he does a great job explaining this to you. The downside is it's like watching SpongeBob do math. This guy is, I think he was an elementary school teacher or something, maybe middle school, but he is very excited. Okay. But you won't forget, which is the important thing. Okay, but there's lots of YouTube channels that'll do that. But I find, he's got corny jokes. I liked it. Okay, you won't forget. It's annoying. Okay, he's good. All right. What else do we have to do? We had to say we're going to test some function notation. we're gonna do a f of a plus 2 here. Okay, I think we did this. So we have our 9x squared minus 18x. What is this? Minus 10. And that's my f of x. And they want, what's f of a plus 2? Okay, so 9, and then we have a plus 2 squared, right? Because everywhere C and x, we're going to replace it with a plus 2. Minus 18, a plus 2, minus 10. All right, so let's go through and do that. So we have 9, and then we have, right? We have a squared plus 4a plus 4. Because all I did off to the side here, oops, was I did that, right? I multiplied a plus 2 times a plus 2. And our firsts, right? We have a 2a. Our outers, we have a 2a. And then our lasts, we have a 4. So this is a squared plus 4a plus 4. Minus 18, a plus 2, minus 10. So why did you factor this out? Because I'm terrible at distributing. I will forget the second one. So to do that, I'm going to make sure I do all my distributing on one line. So 9a squared, 9 times 4 is 36. 9 times 4 is 36. We're going to have minus 18a minus 36 minus 10. Okay. And now the only thing left to do is we're going to combine like terms, right? We're going to group stuff. So we've only got one of these. All right. We have A's, right? How about our A's? We have A here, 36A. We have a minus 36A. Okay. So we can group those together. And then, I'll go back to page, sure. We have a 36. We have a negative 36. We have a negative 10. Okay. So all we're doing is we're grouping all the light colors with light colors. So this is going to be 9a squared, right? I'm trying to use more colors. Plus 18a, because 36 minus 18. And then I was a little intimidated by this, like 36 minus 36. Oh, thank goodness, those go. And then we have just a minus 10 here. All right. So that is what we have for that. Okay. Hey, that should be a minus, shouldn't it? So minus 18a. All right, and that's what you're supposed to get for this. All right. So we found the intercepts and we found f of a plus 2. All right, we'll come back to that one in a second. Nah, we'll do that one. All right. Okay, so let's see here. We have x squared plus y squared. We did a little bit of this, right? Complete the square. Okay, so the first thing we're going to do is we're going to divide these into the x's and the y's. So we're going to go ahead and say x squared plus 10x plus y squared minus 14y is equal, and we're going to put that negative 38 on the other side. Okay, and now we got to complete the square. We got to figure out, like, what magic number am I going to add to both sides that's going to make this factor? And the way we do that, right, is we say b, take the middle term, b is equal to 10. And then we're going to do half of that. You can do bx, because we're dealing with the x sides. And then what we're going to do is we're going to go ahead and square that. And this is the magic number that's going to help us factor. Okay. So when I go to factor this, right, this is going to be x plus 5 squared. You notice that we have a b over 2 is 5, and we also have a 5 over here. That's always going to be like that. Okay, so if you get lost, you're like, oh, I can't remember how to factor this. This is why I tell you to write it down. Like, you will find it. okay, plus, and then we have to do what said with this one. We have to say, okay, well, let's go over here. We'll say by is equal to negative 14. Half of it is negative 7. And then I'm going to square it. Okay, now, just to remind you that if you're doing this in your calculator, that's okay. I wish you wouldn't, but that's all right. I have those days too, clearly. Okay, but if you put negative 7 squared in your calculator, it comes back as a negative number. You should remember that you are smarter than the calculator, and that negative 7 squared is a positive number. It's 49. Okay, what the calculator thinks you mean is this, whereas you meant that. Okay, so even if you forget to do it that way and you do this, just realize you're going to make it positive and then go through and do that. Okay, so we're going to add 49 to both sides. So this is going to be y squared minus 14y plus 49. Don't forget to put it over here. Okay, again, that's one of the biggest things students will do is they'll put it over on the side, and then you'll get the wrong answer because it's not balanced. They get so excited. Okay, and then we're going to go ahead and factor that. Okay, and what's my b over 2? Minus 7. So this is y minus 7 squared. All right. So this is another topic. It's called complete the square. I don't have anybody's YouTube channel, but I really liked how they did it. And there's lots of different variations on the theme. I learned this completely different than the way I teach it. I hated the way it was taught. It involved a lot of borrowing, and I couldn't keep up with it. Honestly, it was really confusing. But you might feel that way about this method. That's okay. Okay, there's other YouTube ways of doing this, and if you need this, it's called complete the square. You could search for it. It's almost always at this level. There are a ton of variations because there's little things that could happen to make this harder. We are not making this harder. This is exactly the level that it needs to be. Okay, so if you're looking at something and they got a 3x squared and you know, plus 21 x's or something, let's go with 11. Make it hard. Okay, and you're trying to figure out the number here, and it's like, wow, there's a lot of fractions. Yes, there are. It's going to be hard. We're not doing this. Okay, it's not going to get that hard. So you can keep it to the fairly simple condition because we got a lot to do with this, right? We're also going to figure out a circle after we're done. So we have negative 38, 25, and 49. I think that's going to be what, 74 minus 38, right? It's 50 plus that is 75 minus 1. There we go. So that's going to be 6. Oh, look at that, 36. Yeah, it's almost like somebody planned that. Okay, but there's my circle. All right, where's the center? Remember, the negative sign is part of the formula. So the center is, this is really x minus a negative 5, isn't it? If I was going to write it with the negative sign. So the center is negative 5. This one's okay, 7. Okay, so just remember that negative sign belongs to that formula. And then my radius is the square root of that. That's r squared. Our radius is just going to be 6. And now we don't worry about plus or minus with this because we just want the principal square root. And we don't want a radius that's negative because then we get like an inside out circle. That might be messy. So we're just going to leave it as a regular positive. Okay. And then I had them graph it. Okay. But we know where the center is, right? It's negative 5, 7. If I was going to graph it today, I'd graph it this way. All right. Put the center of the page. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And then we have to go 6 up from everywhere. Okay, so 6 down. 1, 2, 3, 4, 5, 6. We're going to be down here at 1. 6 over. 1, 2, 3, 4, 5, 6. All right, and then we go up 6. So it would be up here at like 13. negative 513 here. And then 6 in this direction, right? Negative 5 minus 6, negative 11 here, right? And then we would just kind of hope for the best as far as it being round. All right. My rule for everybody else for that was like, if you could draw at least as well as I can, you've made a good circle. Okay, and my drawings are terrible, so you're going to be fine. All right. Now, this last one, okay, this is a scary problem. We've since revamped the intermediate algebra class so that we don't really deal with this anymore. So I would not ask you a question like this on an exam, simply because we don't really cover it in the same spot anymore. All right, so this one, I wouldn't ask you. All right. This one, I think we did one like this in Alex. I'm not sure, but I would double check to see if we did. If we did, then something like that's fair game. That's okay. And this one, I know this one is an Alex. This one is definitely fair game. This is my favorite problem for circles. All right. So there we go. Let's see here. I wonder, hold on, I just want to see something. So again, we move things around. No, we're not doing that yet. We did some of this though, right? We did some of this. Function transformations. All right. So we could definitely look at number 2. See, we changed things around. Well, there's also this is for the second 2 weeks, which we're in right now. Okay. So the quizzes, you have to remember the quizzes are more frequent than the tests. Okay. But what if I gave you something like this and I said, well, we're going to figure this out. Okay. So again, you can see like what's the difficulty level of the transformations that I picked. All right. If you had to do it by hand, what are we doing? Okay. So we have a function. All right. Here's my f of x. Okay. And all right. And then what do we have? What's going on with this? What is f of x minus 1 plus 2? Well, remember, this is a horizontal shift. And since it's negative, it goes to the positive direction because horizontal stuff works that way. And then plus 2, we have a vertical shift up. Okay. So for here, tell you what we're going to do is we're going to do it this way. And then I'm going to draw in a lighter color. How light is this? Okay, barely legible. All right, so what we're going to do is we're going to move everything here, right? 1 unit to the next spot. So that's going to go here, it's going to go here, this one's going to go over here. So let me sketch this one in with a little bit darker. All right, so we would have something that looks like this. This one's going to be 1 over, so it looks like something like this. All right. And then what we're going to do is we're going to take each of these things, we're going to push them up by 2 points. So instead of a 0, right, here's 1, here's 2. All right, I feel like I'm playing the piano here with I got my things crossed. Okay, so here it's going to be the 3. Okay, oops, where are we? We're oh, sorry, we're here with this one. So here we're this one. We're up here 3. This one's 2. Get rid of that. Staring at the wrong one. All right, we should be staring at the light green one here. This one's going to go up to 2. This is -1, 1, 1. And then we're going to go back up to 2 again. So we're going to be, all right. Again, Alex does a really good job. I love their tool for this. I definitely would want to keep using that. So, because you can just drag it, right? That's all you have to do is just drag it. So we're doing transformations. Remember, this is what transformations will do. Okay. And again, I missed the before time so much. But notice there was one whole question where all I asked you to do was figure out horizontal and vertical shift. Okay, that's a fair question. Okay, then we put the negative out in front. What does the negative out in front do? Well, that's a vertical, right? That's a vertical reflection. Okay, so this one, let's go back to blue here. Okay, it's my vertical reflection. So we have our, and then this point has to come down here. The 0 doesn't change. The 0 doesn't change, but this point's going to come up here. Okay, so my vertical reflection here is that color, right? That's it. There's my answer. Okay. So 1, where there was vertical reflection. Okay. And now this one was harder because it's on the inside, so it's a horizontal. Is it a compression? Is it an expansion? Remember that horizontal stuff does the opposite of what you think it does. So if it was on the outside, you'd think, oh, that's compression. No, it's an expansion. Okay. So we have our value here. Okay. And then we are going to string this thing out. All right. So instead of here, this point is now over here. This point is like way over here. Okay. So it starts at the same spot, but this one is now. All right. And again, Alex does a much better job than we did by hand. But I also want to call your attention to this, right? You had how many hard ones, how many easy ones here? Right. We had these. I thought this was a fairly easy one. Actually, I remember this problem now, and the students proved me wrong. I thought it was an easy one. They told me it was not an easy one. Okay. So be careful about where the negative sign is. And then this one, I knew this was a hard one, which is why there's only one of them. So if you get the easy ones, right, that's 2/3. It's almost a C. Okay, so you don't have to be responsible. Like once you start getting to like the hard ones, like realize I'm not going to ask you a ton of hard ones. I'm going to ask you more easy ones, and then 1 or 2 hard ones. Okay, because I think if you do your homework, you should be getting a C in the class. I think that's at the very least, that's what we're going to go with. At least that's what I'm going to try to aim for. So if you're doing your homework, you're like, oh, I got these were easy. Good. You get to this one, like, oh, I don't know. Like, well, okay, don't beat yourself up. You got 2 out of 3, right? That's 67%. There's other problems you're going to do well on, all right? So by the time we're done, that's going to be a C. All right. We can hope for it's better, but, then you have to be able to do the hard ones too. Okay. All right. And then this problem, did I ask for it? Oh, I did. Oh. Tells you when I wrote this problem. Good Lord. Okay. Okay, it says the average level of a water. I don't know, did we do linear equations? Hold on, let me check something. Oops, wrong one. Let me check here. I want to do Alex. We did circles, we did functions. Oh, linear equations. There we go. Point was 1.5, modeling linear equations. So that's where we are. Okay, so this was like 1.6, 1.7. Okay, no, just looked at it. 1.5. Okay, this is a 1.5 problem. Okay. Okay, the average level in the water retention is 6.8 feet. During a drought, the water level decreases at a rate of 3 inches per day. Rate a linear function that represents the water level in feet t days after the drought begins. Evaluate W of 20. Interpret the meaning in the context of this problem. Okay, so the first thing you got to do is figure out, well, whoever wrote this problem is a jerk because they gave us inches and feet. So what's going on with that? Okay, so we can't use 3 inches per day. We have to use how many feet is 3 inches, right? So we have to say, well, this is 3 inches, right? And we're going to go ahead and say, well, there's 12 inches to 1 foot, okay? The people who are doing construction are looking at this like, why did you do why did you do arithmetic? Because the rest of us need to. Okay, so that's 1/4 of a foot per day. It's 0.25 feet. Okay, because 3 over 12, right? It's 1/4. Okay, write a linear function. So what we're going to do is we're going to say, okay, W of t is equal to, wait, where did it start? It started at 6.8. And then we're going to take away 0.25 and then t, right? And t is equal to number of days. W of t is equal to water level in feet. All right. So when you're confronted with a word problem like this, sometimes I like to make a list of the variables, like what do the letters mean? Because that way it'll help us keep this a little bit straight. Okay. So there's our linear function W that represents the water level in t days after the drought begins. I think we're good. Evaluated at 20. What does it mean? Right? What does W of 20 mean? Okay, so this is negative 0.25 times 20 plus 6.8. And you might be thinking to yourself, I hate these questions. I never know what it means. So plus 6.8. All right, that's 1.8. Well, that's why I wrote down the letters over here, what they meant. That means in 20 days, the water level is 1.8 feet. That's exactly what I was looking for when I wrote this problem for them. Okay, in 20 days, that's what the 20 here means. 20 days, the water level is going to be 1.8 feet. Just run this through, give me the answer, tell me what the units are. That's it. Okay, so that's, I don't remember what book I stole this out. I did steal this out of a book. I don't remember which one though. But that's the kind of, just to give you an idea. Okay, we can play a little bit more with some of these. Tomorrow we'll try. This was the average rate of change problem. Okay, I think we had a couple of these too, but I'll double check. Okay, I'll double check. I think that's in 1.8 in your book. Yeah, we ain't there yet. We're not at 1.8. So I wouldn't put that problem on. We're not ready for that yet. Okay. But yeah. So I will put together, I will put together your exam this weekend and have that released to you. And next week we are just going to go through and review more of what's going on in here. Okay. And you can see like what's it going to be on? Okay, we're not doing anything we did yesterday. All of the sections, 1.2, 1.3, 1.4, 1.5, 1.6, that's a lot. All right, and then we're here. I don't think I'm going to put the knowledge check stuff and the review stuff here. I think there might be an occasional, there might be an auxiliary question like this that's going to deal with some of these. But I'll try to keep that to a minimum because I've already got how many sections? Right, I've got 1, 2, 3, 4, 5. I have 5 questions. Each of these have multiple topics in them. By the time I get done writing like a 15, maybe a 15 question quiz, that's 3 questions per topic. Okay, and I don't even like to do that many, so it's probably closer to 12. Now we're down to 4 questions. You know, we're down to you know, about 2 questions per topic. So there's not gonna be a lot of time for me to ask you a whole bunch of other stuff from the knowledge checks. All right. All right. So let's go ahead and call it there. Okay, this is Wednesday, so we have one more day tomorrow. We'll start going through some of this as well. I guess I could try to post some of this stuff. So I'll try to do that. So that way you guys have a chance to see what's going on. Okay, and figure out what other questions. These are not your quizzes. Your quizzes are going to be in here in the Connect. This is not going to be for you. Okay, but you know, I picked these problems from somewhere. Okay, they came out of some algebra book, and so this is what I gravitate towards. Okay, we'll call it there. I'm going to go ahead and do that. Do we know when the test will be? Next week, it'll be. I will try to get it released on Sunday, so it'll be fresh for Monday. I won't promise. Tuesday at the latest, though. Okay, the class after yours had theirs released on Tuesday, so it goes from Tuesday to Sunday. All right, so it'll always be due Sunday, 11:59 p.m. All right, but since we already have a thing here, we'll be okay. All right, so all right, everybody, have a great evening, and I will see you tomorrow.